Okay.
Viviana, I'll tell you when there's 10 minutes left and 5 minutes left.
Okay. Can I have 20 minutes? Oh. Good afternoon. I'm very glad and very honored to be here with you, colleagues and teachers. My topic, my work is to compare two paths, two ways for knowing. I've chosen this topic because only because it's a very important topic, a very important content in the history of philosophy. And when we were starting with the project work at the classroom, we were studying Plato and Aristotle. Then, okay, I have only an except one. I have Plato and Aristotle. In this I have five or concepts that the student must learn. I would like my students learn at first Plato and the characteristics of Plato that uses to symbolize the image, draw myths, and so on, and the characteristics of Aristotle that uses the inductive and deductive reasoning. Inductive and deductive reasoning, the students already know this content since the lesson about Socrates. Inductive and deductive reasoning is a prerequisite. So Aristotle is proceeding with the syllogism. The third core concept is to compare two kinds of reasoning. Can have some limits. Plato appears sometimes too much conceptual. Plato is sometimes detached, far from the reality, and Aristotle is too much related, too much linked, connected with the reasoning, with the rationality. And then, at last, another core concept. Teachers and students are often in discordance. This is very important for me because it's possible to extend the knowledge. Is the a way to extend the knowledge. Okay, this is the CLIL plan, my CLIL plan. My CLIL plan is divided in three parts. This is an introduction, the learning phase A and phase B. The age of learning. In my class, we have, are very lucky, we have students with B1 and B2, 4 students with B2. The third class of Scientific Liceo Rende, Liceo Scientifico Pitagora. The subject is Plato and Aristotle. We have a manual, textbooks, in the pages, and the prerequisite knowledge. Plato and Aristotle are ancient Greek philosophers and something of deductive and inductive inference. Learning phase A is to compare Plato and Aristotle, relation between between two ancient Greek philosophers. Plato and Aristotle were a teacher and his disciple. In this column we have the exercise with microclaw and the minutes I need for my activity. I need 2 hours and a half, 2 hours and a half, less, more or less. And in this column we have what what I like my students learn. We have the skills in order to the exercise, okay, the skills, the little objective, the skills, the goals, okay. Learning phase B is only on Plato and Aristotle, with a little conclusion. For Plato I need 1 hour only for the exercise, and Aristotle too. For Aristotle too, only 1 hour only for the exercise. We will see then after the exercise, and these are the contents and the CLIL plan following the MDG methodology, materials development guidelines. Okay, I give you another page for more informations. We have the subject, the topic, and my vision. What my students must understand is that there are different models and ways to think and to know, or to formalize a phrase, or to formalize a sentence. We have different models, not only one. How we can know better? How we can know better? This is an ask, a suggestion. We can start with an ask, with this ask. How we can know better? And this ask remains on suspense, for makes more attractive the lesson. The lesson skill to part, and the some model for formalizing a sentence. In this point L2, we have not only the goals for the English language, but the English language with the philosophy, and when it's possible to work together, okay? When it's possible. And then here we have a little syllabus of the lesson, grammar rules, and syllabus of new words: parapet, knowledge, conjecture, belief, illusion, wearer, syllogism, mammals, warm-blooded. Because it is possible to teach together, to work together, the English teacher and philosophy teacher. Okay, Plato and Aristotle, we have this image. This is not original exercise, you know, but the links are obligate. This exercise, many exercises are based on the intuitive and logic vision. It's impossible to link this and this. It's very, very easy. So for rewrite and reread, okay? And this, try to connect the sentences to Plato or Aristotle or both in order to the picture. He was the oldest between them, is easy. Okay, about the Plato, insert the word below, what's below. with this exercise, they learn new words, but are easy, very easy words. But the concept, the content are very high, I think. After ending, connect the three sentences with Plato or Aristotle or both. They have to connect three phrases. These three phrases to Plato and or Aristotle. This is the first part with the Plato, the myth of the cave, and is the famous myth, the famous tale to demonstrate the passage from ignorance to knowledge. And I think this is a very important point of this activity, because with only 7 digits, we can remember always the content of the myth of the cave. We have new words, prisoner, shog, and so on, but are very, very easy. New verbs to get away and stop. They are very, very easy, these words. Okay, this is similar because my students say that it's better don't have a great variety of exercise, because the risk is to have settimana enigmistica at first, when we don't have a great experience. When we have a great experience, we can improvise, we can insert a lot of kind of exercise. They say, I don't think, but they say. Okay, this is not important, a repetition to consolidate 7 digits. Here we have new words. The Platonic line to know is very, very important, and I added the Greek and Italian words too. And recall this pic because the students have to put in the correct place the 4 words below. Before 5, we have before 5 conjecture and belief, and after 5 we have thinking and knowledge, the true knowledge. The 5 is obviously the willpower, a great concept in Plato, and this is an intuitive knowledge. Okay, critical thinking. In critical thinking, I insert some joke, and I think this is very important for the corrective feedback. For example, I insert this phrase. There are some people who don't want to work, and so they are always sitting. It's possible, but it's not correct. With this answer, I have a great feedback from my class. Correct answers is we have our knowledge within our mind, and the reality helps us only to discover that for Plato. Okay. This is very important. According to Plato, the true knowledge can be, and final feedback and assessment too about Plato. It's not a swift journey. It's not an imposition, and it's not an illusion. It's a challenge. if you can see. What do you need to know? Courage. We must be brave. Aristotle, the importance of the experience. A jaw. I insert a jaw. Aristotle, he was child. Because the experience is most important, but the cause and the use of the syllogism is important, because with the syllogism, with the we need a good model to communicate. We need a good model to communicate. How we communicate, how it's possible, how it's possible. What's the best model to communicate and predict? This is the similar. The syllogism is a perfect model to know. The students don't know what the syllogism is, but the links are obligate. Search in exercise above the sentences that answer to the following test. What the syllogism is the best model to know for Aristotle. And the syllogism consists of a major premise, minor premise, and conclusion, so on. This is an example. This is a syllogism important to advise, to prevent. It is important to communicate scientific contents. And we have here an example of syllogism. Of the fires burn, this is a fire, this fire burns. This is the Aristotelic syllogism, deductive syllogism. Therefore, another, they have to put in order the sentences below. Create a syllogism, another, if you want. But we have two kinds of syllogism. Not syllogism, all the syllogisms are the same. This is not scientific syllogism. And this is a scientific syllogism. All spheres are round. All apples are spheres. All spheres or apples are round. This is a joke. All spheres are round. This is a scientific syllogism, but I don't know it. What's the difference between the scientific and not scientific syllogism? Try to see, transcribing the two syllogisms, and recognize where is the mistake, recognize where is the error. Try to transcribe. When I see, I can see the mistake. I rewrite and transcribe the two syllogisms above. What's the problem? There we have the solution. In the scientific syllogism, the major premise must be true. In the first syllogism, the major premise is false, because not all birds can fly. Not all birds can fly. And therefore, the first syllogism is a not scientific syllogism. Only one thing. I think this is the most important part of my activity, because it's like metacognitive instruction in learning of my students. Because the students can see themselves when they are studying. What are we doing? What are we doing? We are studying the syllogism, and we can explain what the syllogism is with a syllogism. With a syllogism. This is a metacognitive example for of learning. This is conclusion, new assessment sequence. They have to put sequence, and then there is this. We have to put in the correct side the words below. Okay. The most difficult verb is I beg to differ, so that is very elegant. And okay, I conclude. Thank you.
20 minuti, eh?
Quanto? 20?
So, I gave you the 20.
10 postate, 10 minuti di spolamento.
C'era anche la musica,
Abbiamo visto che
Music, I was trying to...
partiva qualcosa.
Music. Okay.
Okay, next.
Oh, forgive me because I have forgotten Janet Jimenez. I will add Janet Jimenez. Whoa for Janet. Thank you.
We need to have someone.
Thank you.
Che sedia.
It doesn't screw in.
Good afternoon to everyone.
No, I'm not bored.
Okay, right. Good afternoon to everyone. We are going to show you our project work, whose title is Finding the Exact Area with the Definite Integral. This subject relates with one of the main topics in the last year of the classic and scientific lyceum. When students approach to this problem, they generally are concentrated to the mathematical applications, and they are less interested in the theoretical aspects of the subject. So we thought that this subject if we approach this subject with a CLIL approach, maybe students can fix these concepts that are important for the next application. What we would like to hear at the end of our activity is in this excerpt. It has a few sentences written in academic language, written in with strict definitions and with appropriate terms. And around it we have 7 micro CLIL, because we give our students each concept with many exercises. The first 3 slides we have our plan. Back. The first 3 slides contain our plan with the micro CLIL content. The age of the student is about 18-20, and the class has about 22 students, and the average English competence is about to be 1 upper B1. Our activity moves from a practical situation, because the knowledge is not pre-taught and all information is new for students. So we give them a practical situation. We give them a map that shows a new school playing field, and we ask them to calculate the area that students have for their sporting activities. At first we have 2 exercises, O0 and O1, that are prerequisite knowledge. In the first one, they remind some concepts they will know because they met them during the year. And then they rewrite the definitions with the correct, looking at the correct notation. When we give the map to the student, they have to put these sentences in order to form a well-written paragraph. The content is new, so when they write the sentences, rewrite the sentences in the correct orders, they have the first idea of the problem, that is to calculate the area of some regions. In the map we have 4 colored surfaces. 3 of them are geometric shapes, well-known geometric shapes, but one of them, called P, is a pool, and it has a curved line and 3 segments, so it's not easy to calculate the area. We then give, this is the exercise in which they put in order the sentences. Then we give them this sheet in which they try to compute the colored areas in the map using the information given in it. We give them language, we give them the formulas, so that they can in 5 minutes calculate the value of the area. But when they arrive to the last one, they have the length, the width, and also they have the expression of a real function that represents the curved line. But they can't find any formula for it. So, while they are doing this exercise, we observe them, because we want they discuss about the area and about how could they can give an approximate value of the area, of the same area. Focus of this exercise is on content, obviously, because in the first one they met for the first time the concept of normal plan domain. At the just a moment. At the end of the activity, they will be able to calculate only some areas that are the normal plan domains. They discuss about the problem of the area of P, and we want they reflect on this problem. When we don't have the solution for a problem, we try to give an approximation of the solution. And also a better approximation sometimes is better than nothing. So we try to find out a way to calculate the pool area in this way. We give them a practical activity, and so they can learn by doing. We give student working pairs. At first they have 2 sets of rectangles, the green rectangles just a moment, I explained it before. They have green rectangles and yellow rectangles. One student has a set of green rectangles and a set of yellow rectangles. The other one has blue rectangles and red rectangles. They have to cover the space of the pool, so that they can observe that when they use the yellow one or the green one, they have an approximation by defect. And when they use the blue ones and the red ones, they have an approximation by excess. So they can deduce that the area is between the blue, the green and the yellow rectangles and the blue and red rectangles. In this phase they can speak fluently but without a formal language, because they have only a concept, the normal plane, and they ask teacher some questions and the teacher answer them without any academic language. What happens is here. This is the first approximation for defect. Then they use the yellow rectangles and have a new, better approximation. In this exercise, they meet for the first time a new concept the inscribed rectangles and circumscribed rectangles. This is the first approximation for axis, by axis, and the last one is this approximation. In exercise 5, they work in pairs and they reflect on what they made in the previous exercise. So we have an assessment moment. They notice that the region covered with the different sets of rectangles give them an approximation, and when the width of the rectangles approach 0, the area is the same, both with both of the set of rectangles. And now
So
I pass.
okay. With the microglow tool, we decided, discussed about the strategy to go through this topic, and we decided to give students this exercise where they are invited to move the pool into a Cartesian plan, where they can see that the curvilinear side is a well-known function. So they know that they have to think about this situation from a mathematician point of view in this case, and we let them to reflect on the fact that this area is a normal plane domain. So the approach is that they have now to, we give them a dissection with 5 sub-intervals, and they have to draw 5 rectangles, inscribed rectangles, and at the same time they calculate the value of the function in the point we give them in a way that we guide them with this example. They have to calculate f1 in this way, for instance. So they calculate the minimum and the maximum of the function. They know is the height of each rectangle. And then, so this is the focus of this exercise is on content. They draw, so this is a situation when they draw in the figure, so this is something they construct on their own. And then they reflect on what they have done the previous exercise. But first of all, the focus is on language in the exercise, because we ask them to put the right article in this paragraph. Doing that, we introduce a new microclaw, which is inscribed plurirectangle and circumscribed plurirectangle. Before it was rectangle, now plurirectangle. So we scaffold step by step, construct the new concept this way, and then in the next exercise they work in pairs, and from what they have already done in figure 1, one of the exercises they did before, they calculate the area of the sub, of the inscribed and circumscribed rectangles. This is just a phase where they do something practical, very practical. Then, in exercise 9,
at this moment we have only few concepts. Inscribed rectangles, circumscribed rectangles, normal plane domain, and inscribed and circumscribed plurirectangle. Moving from exercise number 9 to exercise 15, we have a new phase of learning because we are moving from an informal language to a formal language and to a new approach, the mathematical approach with a mathematical procedure. So we have in exercise 9 two new concepts, lower sum and upper sum. That is the sum of the described rectangles and the circumscribed rectangles. So they calculate this value using only 5 rectangles. Okay. In exercise 10, we want to double the equation. So we have just a moment of assessment, of linguistic assessment with explicit focus on language and implicit on content, because they reflect again on the 5 rectangles. In exercise 11, they haven't any guide because they have to calculate the lower sum, the upper sum with the 10 sub-intervals. So they have to calculate the minimum and the maximum, and this is more applicative than the other one. Okay. Now we are going to the last exercise of this middle phase, that is the exercise 15, where they work in 5 groups, so that at the end they can understand the trend of the lower sums and the trend of the upper sums, and definitely they notice that the area is always between an increasing sequence and a decreasing sequence. They can, in exercise 16, have more vocabulary. On the left we have the keywords, and on the right we have the strict definitions. And in exercise 17 they have a listening. We hope to do this listening with the interaction of an English teacher, because we want to equilibrate always during our activity the content, the cognitive content and the cognitive content language. So they fill in the gaps. In the gaps, the keywords we give them. And just another thing, notice that we gave them at first the word, and then they write it in the gap after they listen it.
Okay.
So
Now we are going to through a phase where they have to formalize more and more the concept we have already seen, because in maths it's mandatory. They have to think and to use specific words, a specific language, and we don't want to simplify too much. We want that they use the specific language. So, as you can see here, they have to use n rectangles, so a dissection with n points, and giving them always exercise where they have to focus on language and then on content. We allow them to think about, to think carefully to what they have already done, and in a new way, in a more formal way. So, for instance, they have to find the right word to put here, and then the right answer to these questions, and then they have to rewrite them. This is an haptic exercise, because they have to know how to write the maths words, not only how to pronounce them. Then we have another function, which is whichever function. They here formalize, write them the keywords here. We expect they at that point are able to do this, and then here this is an assessment for us. This is an exercise where we give them the sections in whichever function. They have to construct subintervals, inscribed and circumscribed rectangles. Here we go on with the academic language, talk about increasing the sequences, for instance, decreasing the sequence. And then in this exercise they have to put in order these sentences to have a well-written paragraph, and this is a content exercise. The focus is on the content. And we introduce the symbols, for instance this one for the first time. And they understand that this is a way to represent the symbol they have used here, the sum, sorry, I don't remember the right way to call it, the sum. And they understand that this is a value of the function in a subinterval, which becomes more and more thin step by step. So this is the value of the area of each subinterval. At the end we introduce other terms, other keywords, with an exercise which is both language and focused on language and on content. And at the end we expect that in this picture they are able to label in the right way. At the end we put this image. And we haven't used the concept of limit until now, but they have already studied it, as my colleagues know. This is topics we do at the end of the second term, the last year of the second school, so they already know the meaning of limit, and so they can intake this concept. I hope. This is the end.
Dobbiamo collegare questo?
The scarf.
C'è il corso inizia